For video 3 of inequalities and applications, we're now going to look at the multiplication principle for inequalities. So starting off with our example again of 5 being less than 12, I'm going to take my inequality and I'm going to multiply it with a positive number on both sides. So let's say that we're just going to multiply both sides by 2. In doing this, we get 10 is less than 24. And again, we want to make sure that we see that we're getting a true statement here. This does check out. 10 is in fact smaller than the number 24. But let's go ahead and this time multiply both sides by a negative number instead. So let's say that we multiply both sides by negative 3. By doing this, we get negative 15 is less than negative 36. This statement is incorrect, and let's take a look at it on a number line. As we can see on this number line, negative 36 is further down to the left on the number line, which means that it is a smaller number. So we need to correct the statement that we have here. The easiest way for us to do this is to simply flip the inequality sign. So now we're going to say that negative 15 is greater than negative 36. Sometimes it helps to think of this in terms of money. So it would be not as bad to be $15 in debt as opposed to being $36 in debt. So this is why we would say that negative 15 is greater than negative 36. So now we've come to our general rule. Let's go ahead and work with the variables x and y, and we're just going to say that they're real numbers. Then we're going to work with the variable a, and I'm going to add an extra restriction on it, and I'm going to say that it has to be a positive real number. So if we are looking at the general example and I'm saying, all that I'm going to tell you is that x is less than y, if I multiply both sides by a positive value, in this case a, then the inequality symbol, less than, is going to remain unchanged. The same goes for the situation where if x is greater than y, then when I multiply both sides by that positive number, denoted by a, then that inequality symbol will stay greater than. Also, just to note that I can rewrite this rule with the greater than or equal to sign or the less than or equal to sign, and it will still hold true. Essentially what I'm saying here, denoted in blue, is multiplying both sides of an inequality by a positive number does not change the inequality symbol. You can kind of just ignore it. It's going to stay just as it was presented to us. We have to be careful, however, when we are working with multiplying with a negative number. So in this situation, let c and d be any real numbers, and the variable z is going to represent a negative number. So if I multiply both sides of an inequality with a negative number, then I'm going to have to change the direction of the inequality symbol in order to maintain a true statement. And again, this would work for situations where you're using less than or equal to, or greater than or equal to. So again, multiplying both sides of an inequality by a negative number flips the inequality symbol. The other thing that I want us to note here is that when we're talking about this multiplication principle, it also applies to division. So again, if I divide both sides by a positive number, then I do not change the direction of the inequality. However, if I am dividing both sides by a negative number, I will need to flip the direction of the inequality symbol. Let's go ahead and get some practice in with regards to this. So what I would like you to do for each of these two problems, solve, then graph, and then write your solution set using both set builder notation and interval notation. When you're ready, go ahead and hit the play button and we'll review these solutions. So for our first problem, we have negative 8 times y is less than or equal to 3.2. So to begin to solve this one, we'll go ahead and we'll divide both sides with that negative 8 in order to reduce it out on the left side. It's negative 8 divided by negative 8 reduces to a 1. 1 times y is just y, so we've met that goal of getting the variable isolated. The one thing that you do want to note here is that I am using a -8 to complete that division on both sides of the inequality. And because of that, I need to change the direction of the inequality that I'm working with. So as you can see on the second line, this is why we have a greater than or equal to symbol instead of a less than or equal to symbol. And again, 3.2 divided by -8 will give you a -4/10. We've solved this. Now we're going to go ahead and present it in our 3 different formats. So one of them would be set builder notation, the second a number line, and the third interval notation. So with set builder notation, remember you want to use those curly Q kind of brackets. Then as I have highlighted in purple, we're going to identify the variable that we were working with, which would be y. Then we use that vertical line to represent the words such that. And then we'll go ahead and we just drop in the inequality that we uncovered by solving. When we come to the number line, we'll go ahead and we'll eyeball about where we think -4/10 is going to be on the number line. So I have it placed right here. And again, so it's a little bit past the halfway mark and closer to 0 on the number line. The other thing that I want you to note is, since we are working with a greater than or equal to symbol, this is why we are going to take our circle and we have it become solid. So we're going to fill it in to let our reader know they are allowed to use -4/10 as one of those many solutions that they can work with. So lastly, we'll go ahead and we'll do interval notation. So we always want to note the smallest value used in the shading. So again, our -4/10, and then the largest value used in our shading. In this case, it would be a positive infinity. So we always write this from smallest to largest. So as you can see on the screen. And then we just have to kind of clarify what brackets to work with. Since we are working with a greater than or equal to symbol, which results in a solid dot, this is why we use a bracket here to, again, let the reader know we are including -4/10 as one of our solutions. Lastly, we always use a parenthesis next to an infinity symbol, whether it's positive or negative, because infinity isn't actually a number that we calculate with, it's just the idea of a number that is getting bigger and bigger and bigger. For our second problem of 5/6x minus 3/4, I'm going to go ahead and work with a little shortcut here. So instead of dividing both sides by 5/6, I'm going to multiply both sides by the reciprocal 6/5. And as you can see, everything reduces out to a 1 on the left-hand side, just leaving x, which is our goal. The other thing to note is that I'm working with a positive 6/5 on both sides. I'm using a positive number to take care of that multiplication on both sides. As a result, this means that our inequality symbol stays the same. It will stay less than. From here, we would get -18/20, which we could reduce by 2 to give us -9/10. If you are wondering, well, couldn't I go ahead and do the cross-canceling up here and get that answer? You absolutely can. Sometimes there's going to be more than one way in order to arrive at a solution. So from here, we will go ahead and note our interval notation, set builder notation, forgive me. Set builder is where we use our curly Q brackets. Then we go ahead and do our number line. And again, I'm going to locate where -9/10 is on the number line, and this time I'm going to use an open circle because we are using strictly a less than symbol. There is no equal underneath it. And then again, since it's less than, I'm going to shade everything to the left of that circle. Lastly, we'll go ahead and now do interval notation. And again, our smallest value that we're working with would be -infinity. Our largest is going to be that -9/10. So again, here's my smallest and largest values written in that order. Every time we have a infinity symbol, I always use a parenthesis next to it. And again, because I'm using a strictly less than symbol and my circle is open, this is why I use a parenthesis next to the 9/10 as well. I hope this has been helpful.